So how much gasoline does it take to move a Hummer H1 vehicle enough to rotate its tires by a quarter turn? In this problem, you're given that the fuel economy of one of these vehicles is about 9 miles per gallon, and that the diameter of these tires, wheels and tires, is 22 inches. You're also given some conversion factors. So how do we do this? Well, first thing we want to do is start with what we know. The distance we know is that we need to move this truck through 1/4 of a revolution of its tires. Ultimately, what we want in the end is a certain amount of fuel. So this is really just a unit conversion problem. We need to convert from revolutions of wheels down to milliliters of gas, using the information that you have in this problem. First, we'll take the revolutions that we want and convert them into an angle measurement. And since ultimately we're trying to convert this revolution into linear forward motion, we're going to need an arc length formula to do that. So our angle that we get should be measured in radians. To get radians, all we need is the conversion factor that there are 2 pi radians in one total revolution. Now we'll be down to radians. That angle we can then convert into a forward motion, a linear motion of the truck, using an arc length conversion. And that just takes the form of every 1 radian that this tire rotates, the truck's going to move forward by 11 inches. That's really just the usual arc length formula in a different disguise. So now we're down to a number of inches that the truck will move forward in this 1/4 of a revolution. In order to use the fuel economy information, which is given to us in miles per gallon, we're going to need to convert that distance into a number of miles. And you have a conversion factor in this problem that tells you 1 mile is equivalent to 63,360 inches. So now our distance is being measured in miles. We can use the fuel economy by noting that it sets up an equivalence between 9 miles of forward motion and 1 gallon of gasoline in this truck. That's a conversion factor, which if we use it in a unit fraction with the miles on the bottom and the gallons on the top, will now tell us how many gallons of fuel it's going to take to make the truck do what we want it to do. Now that we're down to a unit of volume of gasoline, all we have to do is convert that number of gallons into the milliliters that we want, using an intermediate step with the conversion factor from gallons to liters that you were given, with the gallons on the bottom to cancel the gallons up top, and then the conversion factor that comes from the metric prefix for milli. 1,000 milliliters is equal to 1 liter, with the liters on the bottom and the milliliters on the top. So supposedly this is going to give us a number of milliliters of gas. To verify that, let's check to make sure that all the units that we need to cancel are actually going to cancel. Sure enough, the number of revolutions, radians, inches, miles, gallons of gas, liters, all of those cancel, and the only unit that survives is the unit of milliliters of gas, which is the one that we want. So we're ready to do all the arithmetic that we wrote down. Multiplying these fractions by multiplying across all the numerators and getting a number, and multiplying across all the denominators and getting another number, and then dividing the former by the latter. Ultimate answer, 0.115 milliliters of gas is what it takes to move this truck forward by 1/4 revolution of its wheels. How much is 0.115 milliliters of gas? Turns out to be about 2 or 3 drops of gasoline is what it takes to move that truck forward by 1/4 revolution of its wheels. What the neat thing about this is it really is just a unit conversion problem. We start out with a quantity that we know that we need, 1/4 of a revolution of tires, and then we use a series of unit conversion fractions to turn revolutions of tires into an angle, into an arc length that tells us forward motion, and then from inches to miles, and we're using fuel economy to convert from miles into gallons, and then from gallons to liters to milliliters using standard conversions.